But I want to start by just thanking everyone for attending today. We're really excited to discuss this project that was a collaboration between ourselves at Integral and HPS as the architect. We're talking about how to getting to zero is the name of the title. We're really focusing on sustainable design and specifically the challenges of sustainable design in healthcare. And we're going to use this MOB as a case study to talk about the strategies that we use here as an example of strategies that can be used in other projects. So as MJ mentioned, my name's Calina Ferraro. I am a principal and mechanical engineer with Integral Group. I lead our San Diego office. And I'll let John do a brief introduction of himself.
Oh, thanks you, Calina. I'm John Spotorno, with Senior Design Associate with HPS, Holly Peterson Snyder, up in Northern California. And we had the opportunity to work together to design this 87,000 square foot, 3-story. You'll hear MOB standing for Medical Office Building. That acronym flies around a lot. So
great. Thanks, John. So just as a brief overview, there are AIA credits available for this session. Really, like we said, we want to identify some passive and active strategies to get to zero net energy for high performance medical office buildings. We also want to identify some cost trade-offs and opportunities that we were able to see on this project so that you know what to keep an eye out for potentially in your future projects. And we'll talk about some of the specific challenges associated with this project as a medical office building that need to be considered when you're designing for healthcare projects.
So yeah, we were excited to receive the first LEED Platinum certified medical office building in Northern California, or North America actually. And we went on to receive the LEED Zero certified. And we've been went on even further than that to the Living Building Futures for energy certification. And of course, the USGBC awarded us a leadership award for Northern California as well. So very exciting, this project, how it grew in fame. And, you know, for me and Calina, we were talking about this, and it feels a little bit like old news to us because, you know, we started this project like back in 2016 and it was up and running in 2018. The beauty of that, or the advantage of that, is we can honestly say that we've reached our targets and we have data to prove that this building has been in operation now for a couple of years and is functioning even better than predicted. And of course, as we know, the climate continues to change, and we'll see how she operates coming up this next weekend, as the Santa Rosa is predicted to be extreme weather condition again. So next slide, please. So these are just, you know, like to fly the flag where we can. So the Platinum Award, next slide. We were able to achieve 85 points out of the possible 110. Next slide. And these are some of the sustainable strategies that we won't go into specifically. A lot of them I'm sure you're pretty much aware of. The site water was an interesting one, not related to energy, but you know, as California is really challenged with water, and recycled water was not an option here because it's used elsewhere 100%. But we moved into a business park that was essentially designed with lawns and conifer trees, and so the city allowed us, and the business park owners allowed us, to make modifications to that landscape to be low water California, which helped a lot, as well as the inside fixtures. So the medical office building, that's a big challenge. As you know, all exam rooms, there's a lot of water use. So next slide.
Important too, John, is not, I mean, there's a lot of text on this slide, but really just to identify that it was a very holistic approach, that we really have sustainability strategies in every category and sort of across the scorecard to get the performance we wanted here.
Again, flying the flag. Next slide.
I think just also to reiterate, for those not familiar with the LEED Zero certification, that's an operational certification. So whereas the LEED Platinum certification was based on design documentation. LEED 0 requires a performance period. So this is, like John said, us being able to document the actual in-use performance.
Similar with the Area National Living Futures Institute. It's a performance-based. And in fact, you can see here that this was a data chart collecting the energy consumption during the whole year.
Yeah, and you can see in that row that's highlighted in orange, where it actually tracks where we're drawing from the grid and then putting back into the grid to get us the net positive, which means we have negative energy use in the overall building. But you can see how it trends through the year.
Next slide. So just a quick, some nuts and bolts. Obviously, it was a team effort. Turner Construction was instrumental in leading us through. There was significant budget challenges with this project as we were in the throes of thinking that, oh, we're up in Santa Rosa, Northern California, the labor pool will be less than the San Francisco Bay Area. That turned out to be incorrect because people were willing to commute, contractors, subcontractors, to the Bay Area. So they had to pay San Francisco prices for the subcontracting of this project. At the same time, their membership, Kaiser's membership in this area is a significant less income level, so that there was a real challenge with meeting the programmatic needs and at the same time getting this under budget. So it's, you know, we call it MOB 6. It's actually cited, if anyone wants to Google Earth it, 2240 Mercury Way in Santa Rosa. We can show you a site map in a second. It's about on 6.5 acres. Again, it's 87,000 square foot, 3 stories, about 45 feet high, and sitting in a parking lot of just under 440 cars. And it was built to the 2013 codes at the time. And it was in the middle of a business park. So Kaiser had a significant presence in the northern part of Santa Rosa. 101 was getting more and more developed and clogged, and they really saw the need to move to the southern part of Santa Rosa to support their membership. So that was what, and they had a piece of property in a business park, and so that's what pushed this project forward to better support that sort of southern western part of the Santa Rosa community. So next slide, please. So we can go into more specifics about the site and the envelope, just to give you a little bit of context. So, and again, starting with the basic building block, 3 stories, what it potentially could be, you have a 3-story building with windows. Next slide, please. What was important, obviously, is start out by reducing as much of the energy consumption as possible through, and I think you all know this, orientation is key. So what you see here is an east-west orientation, which was very important, and it played in nicely to the Kaiser's latest templated floor plates, and I'll get into that more in a minute. The other interesting thing about this is we shifted the building up to the corner to allow for better pedestrian and bus connections. There's a bus stop right out there on the street, and then also catty corner on the other side. And rather than floating the building in the middle of a parking lot, this enabled us to give you the impression as you came in from the street above the main entrance, you were passing a building sitting in landscaping, which was a much nicer presentation. And that did allow for passenger drop-off as you pulled in. Whereas if you can imagine, if the entrance was in the front of the building, you'd have to loop around and chewed up a lot of the site. This, however, created a challenge because the main entry being on the west end of the building, we had to have the service on the east end of the building facing the public right of way. And the city allowed us to do that as long as it was designed with that in mind. So that's how the building orientation, how we were able to zone it to function this way. And Kaiser also has a directive to try and augment healthy living. And so they're okay with staff parking out a little bit farther away and making their way to work every day, as opposed to having the building centered in a parking lot. Next slide, please. So what was key to this, after moving from once we set the building in the east-west orientation, we worked, I should back up for a second, just real briefly, and you'll see this more, that I mentioned earlier that there was a significant budget challenge with getting this building. And so we could not allow one additional square foot beyond the program, just because it was not affordable. And so you see this, what generated, I distinctly remember one of the cost consultants for Turner sitting in the conference room going, we had all these grandiose ideas at the time. And he said, you guys, you're gonna have a box. That was his words. And so we thought, well, if we have to have a box, let's make it a jewel box. Let's make it the most interesting, nicest jewel box that we can. And so that's how the compositions started to develop. And at the same time, we were looking at how we could work with the orientation and play up the window areas. And so because of Kaiser's templates, and I can show you that in the floor plans, generally the public circulation main axes of the building is along the north side, which allowed us to do waiting rooms and their feature stairways, main lobby, welcome zone, all these components of the Kaiser's program oriented on the north side with the large windows. And then the south side, where you have mostly private offices for the providers, we were able to do then much smaller windows using view glass for tinting and reduce the heat gain along the south side. East and west obviously are a challenge for heat gain as well. And so we reduced the amount of windows, especially on the west, to just windows at the end of main circulation paths, which we sort of termed light at the end of the tunnel. So when you're in the building, you can always understand where you are from a wayfinding point of view. Next slide, please. And so this is how the elevations were generated, creating those different window patterns around the program areas. And again, Kaiser has this healthy living and drive to get people moving and exercising. So the stairs were an important feature. So there were the two stairwell exit stairs were pushed to the front outside edge with large windows, and they actually have ventilation, natural ventilation in them. So during certain times of the year, they're not even conditioned. So you see those. And then again, the east-west elevations, you see the end of the workspace and the hallway spaces expressed. Next slide, please. And going through design review, these were some of the patterns we developed. One of the great things, the project early on was, because of budget constraints, was looking at a stud and stucco system, but through Turner's input and Kaiser's national contracts program, we were able to get a composite building panel system, which also enabled the project to go up much faster and much cleaner and provide much better insulation and thermal separation than a stud and stucco system would have allowed. So that was a big gain, and they were able to do it for within the budget as well. So again, the compositions you see on this building are based on these composite panel systems, interlocking systems, and then the different types of glass that were proposed. Next slide, please. So again, this was all brought into it, and as I mentioned, labor was a real challenge. So the panels really helped in the install and the schedule for this project. The other cool thing not seen here is that Kaiser also had a national contract with Connectex. I don't know if you're familiar with that, but it's a steel frame system that's pre-engineered so that it's a moment frame system without the need for welding inspections on site. So it gave us complete flexibility within the building, no cross braces. And at the same time, we were able to set the module to exactly work with Kaiser's templates. So we didn't have a lot of challenges with columns inside spaces and reducing the efficiency. Again, we're going to have a box. We need to make that box the most efficient as possible. Next slide, please. So these were some of the strategies that were modeled into the building in order to reach the goals. And really at the time, this was all about reducing energy consumption. And we hadn't really gotten to the point of, gee, let's go for net zero. That was never Kaiser's original goal at this point. Obviously, they want to do good for the planet. They want healthy humans. And they want a healthy work environment. But they actually, I believe, somewhere around had a mandate at that time, either for LEED silver, possibly LEED gold. But it was sort of the collective growth of the whole team that and Calina will get into this more specifically about the strategies, but it was interesting how it was a domino effect in a good way, how each thing layered on itself as we move forward to get to the point we got to with the net zero. Next slide. So just briefly, me as an architect wanted to just lay out again how this clinic module worked. So Kaiser had this new, at the time, this idea of a welcome zone so that all the patients would come into a main lobby, get oriented. There was community space there. There was a healthy living store. There was a coffee bar. Before you actually got into any of the clinics, behind these walls was the pharmacy and the lab. And then down further was the imaging center. And then further was in that lower end was the I almost said pediatrics, but it's physical therapy, thinking that makes sense to have physical therapy on the first floor. And then there's secondary entrance to allow the bus patrons to come in from that end. And of course, all the service. So, and the lab and pharmacy had their direct access to the parking to the bottom of the sheet to the right there. Next slide, please.
I think,
But
John, just to reiterate what you had said about being able to strategically locate the public facing areas on that north side, so we could take advantage of the larger glazing area on those areas. I think that you can see that in this floor plan better.
Right. Thank you for reminding me. So yeah, the elevators, the stairs and the healthy living store, the coffee bar, and all those things were located on there. But this whole rectangle and the column spacing, everything was driven by, if we go to the second floor, this shows you an example of one of the waiting rooms as we go upstairs, so that they had some large window space facing north. So the second floor, was actually, Kaiser has revisited this yet again, but this was at the time the typical clinic module. So stairs and elevator connected to a public space. There's some public functions all along that, including the restrooms, waiting areas, and then the clinics spun off of that with clinic exam rooms and support spaces. And then all along the south side was the MA stations and the provider offices, as well as the break space. So it really zoned out. Like I said, we organized it to the very last square foot to get this to function.
I think this is a good example too, which I'll get a chance to speak to a bit more on the mechanical systems, but a lot of, the high performance buildings or net zero buildings that we see for other applications use big open floor plans and cross ventilation and sort of daylighting penetrating deep in. And this really highlights some of those challenges we see in medical office buildings, in that we need to have a lot of individual spaces for privacy and for being able to provide those services. So just, understanding the challenges of the building and where we're able to, as John said, we brought in the natural light into the public spaces where those were open. We incorporated some natural ventilation into the stairs that we were able to, and then used this system, the mechanical systems, to serve the more enclosed spaces to meet those healthcare requirements.
So typical waiting spaces and reception greet stations as you come in to one of the clinic floors. There, you'll see that one of the great things that Kaiser did was reach out to the local community. So you'll see in some of these images, a lot of the art and much of that was done locally. We had patient representatives all sitting in a conference room from the different language or heritage groups in the area, cultures in the area, and they all weighed in on what was the best art they thought would fit the clinic. And Kaiser really embraced that so that it really livened up the spaces. So third floor is very similar to the second, a couple of different public functions and obviously different clinical spaces, but as you can see, it lays out very, very similar. Next slide, please.
Great. Well, so I think that was a great overview of the building itself and understanding the programming and the needs of the different membership that we're trying to serve here. I want to take a bit of time and get into the mechanical systems and some of the strategies that we took, again, targeting these ever increasing goals that we as a project team were able to deliver. I think, as John said, it started out as a more modest goal of LEED silver, LEED gold. But as a team, we kept seeing the opportunities to be able to push it further. And this was even within, a design build environment and also with these pretty specific budget constraints that John's alluded to previously. So I think that's just important to keep in mind, is that, I mean, we are talking about this building that has achieved all of those awards and certifications and was delivered within a budget and a schedule in a conventional design build contract. So those don't have to be mutually exclusive. We don't have to just think that high performance is reserved for these, feature high-end projects. It really just takes working together as a team and picking systems and strategies that make sense for the project. So I think, as John said, starting with the basics. So architecturally, starting with the basics means understanding your orientation. From a mechanical standpoint, that means understanding our climate. So really designing for place and understanding where we are. So this is the climate profile for Santa Rosa. What we can see is that, it is a relatively mild climate. So, we do get hot summers. It does get into the, high 80s and 90s for some periods of these months. And it does get down close to freezing. So we do have, conditions that we need to have mechanical systems to condition for, but they're not extreme conditions. So when John put up the envelope performance, I mean, we weren't designing for R50 roofs, right? We had an R23 roof, which is a good roof, but at some, we weren't going to spend our money on insulation that was going to get diminishing returns. We essentially were able to optimize that so that it worked with the climate. Looking at this, we also do see that we've got some good shoulder seasons, which really does give us that opportunity for natural ventilation where we can do it. So within those stairs, we were able to do that directly. Because it's a medical office building, we couldn't do that throughout the floor plate, but that did mean that we wanted to be able to take care of an airside economizer where we were able to. So that was, leaning towards using a central air type system that would let us take advantage of that. And then you can see it, like we said, it does get cool sort of in the mornings and the evenings for a large part of that year. So we do know that we're going to need some heating on those exterior faces. And so keeping in mind a heating strategy that lets us do that. And like we said, as our goals for this project continue to increase, we started to look at how can we do this with an all electric heating strategy. And could we do that cost effectively in order to be able to hit a net zero target? So I think just understanding those basics and letting those inform the design was an important starting point for this project. Now, similar to how the GC, the cost estimator, sat down and told John he was going to get a box, we essentially, started with a baseline of, okay, we're going to have conventional DX gas rooftop systems, right? That's sort of the default assumption of a contractor working on a budget. And in a typical layout, what you would do with a medical office building or even an office building like this is essentially take the building, cut it in half, and assign one system to either side. The challenge that we get with something like that is when the building actually operates, when you divide a building just in half with that previous zoning, the rooftop units on each half have this large interior zone, which that interior space is never going to see the outside. It only sees that there's people and computers and lights in there. They're always going to need cooling. Whereas the perimeter zones, like we saw from the climate profile, we do get cool winters. in the evenings and the mornings too. And so we'll need to be heating those spaces while we're cooling the interior. And that leads to this cooling and reheat uh, cycle that we would get if we zone all of those on the same unit. So we're going to spend energy to cool this unit. And in that conventional DX gas system, we're spending electrical energy to cool it. And then we'd be burning gas at a boiler to heat it back up. And so what we wanted to do was avoid that, essentially two systems combating each other in those perimeter zones. So what we did is took a strategy that we call thermodynamic zoning. And so we really grouped together the building zones that are going to see the same load at the same time. So that means we know our interior space. It's not going to see the outside. It's only going to see the people and the lights and the computers. So that can all be one zone because that's going to need cooling. And then on the perimeter zones, well, in the morning, the east side is going to warm up first. So this zone might not need heating anymore while the west side still does. And then vice versa in the evening, the west side might be hot while the east side is cooling off. And the north is certainly going to be cooler than the south. So what we did is we put each of our perimeters on their own heat pump zone. That means that each zone is only doing heating or it's doing cooling. But we never have to do both in the same zone. So what that looks like, if we look at the floor plan, this is where we can see that that sort of, the chopped up floor plan that's just necessary for the programming actually layers in quite well with this type of a strategy, because we do have very clearly defined zones along our perimeters. Now, you can take this type of approach without having fully enclosed rooms. We can treat those as thermal zones, even if they are open to the adjacent space. But with these fully enclosed rooms, it does lay out very, very logically to do it with this approach. So then looking at what that means on the system level. So this is what that conventional system would look like, right? So we would have a rooftop unit at the top that's going to need to do cooling for that interior zone all the time. So you've got a cooling coil in that unit, and we supply that to this full space. So that would be that original kind of typical box model where we have two big boxes. We're going to have a unit that does the cooling, and then separate from that, we would conventionally have a gas boiler that connects to a heating hot water piping loop that then circulates that heat throughout the building with hot water to reheat that. So the air coming through this duct gets cooled off first at the unit and then gets reheated by that coil in those perimeter zones where we need to do it. So there's a certain amount of complexity just associated with that, just because we've got multiple systems using multiple energy sources. Having to do both of those functions simultaneously. So the advantage that we got with our thermodynamic zoning is that we're not doing both cooling and heating at the same time in each zone. So we can do either the cooling or the heating all up at that unit. So this unit can do either cooling or heating, but it happens at the roof. So the air is already either warm or cool, depending on what the zone needs when it leaves the unit, which means that we can distribute that to the zones as they need it, and it eliminates that secondary system for that hydronic piping, which means that we're saving the energy because we're not cooling and reheating, but it also saves us all of that complexity. So it's a much simpler system. You'll also notice there's a lot less just mechanical stuff on the page. So it ends up reducing the amount of equipment, materials, and also labor for installation by being able to do all of that at the roof instead of needing to run those additional systems. So to give you a bit more of a picture of what this looks like, so this is what that conventional system would look like. So you can see central air handling units, large ductwork from central distribution, taking up that ceiling space, and then running those large duct mains to get to that full zone, and then this separate hydronic boiler system. And you can see the heating hot water piping routed from that to each of these zones to reheat those as they need them. What it looks like instead with our thermodynamically zoned system is much smaller heat pumps for these smaller zones. So we do still have one large heat pump that does that central zone, but around the perimeter, you can see we have much smaller ductwork serving those zones. And all of the heating and cooling gets done by the compressors at the unit. So it's an all electric strategy, and it allows us to completely eliminate those hydronic boilers and all of that heating hot water piping. So that was how we were able to get rid of the gas from the mechanical side for building heating by using these heat pump technologies, because we have to do the cooling anyway. That same compressor can flip a reversing valve and supply hot air instead, because we don't need to do both at the zone. We just do one or the other up at the unit. So we were able to get the gas out of the mechanical system. The next thing we did was we looked at our plumbing system and said, okay, well, if we don't need gas for any of this mechanical system, does it really make sense to bring a gas service to this building just for the domestic water? And the answer is no, certainly not here. So we, in this case, also employed a heat pump technology. So this is, again, a compressor-based technology where we're able to pull heat from the air using that compressor, and in this case, put it into the plumbing water to heat up our domestic hot water. So we were
Yeah,
able to get.
I was just going to say, Calina, you mentioned, I forgot to mention that this was a greenfield site to begin with, so gas service would have had to come from the utilities in the street. So there's a significant cost as opposed to maybe an existing building renovation that had gas already.
Right, exactly. So once we realized we could get rid of gas for the mechanical system, we thought, okay, well, if we can get rid of that gas service entirely, that'll be a cost savings again to this project, which, you know, of course, given the budget, everybody was interested to hear about the potential cost savings we could get while we were still achieving better performance. So I want to take a minute and just kind of discuss that, the difference in these technologies for a gas source for heating versus this heat pump source for heating, because I do hear this conversation quite a bit as we're talking about decarbonization and all electric strategies for more and more buildings. What I often hear is the question of, okay, but does it really help to change to electric, because aren't we burning gas at the power plants to generate that electricity? Um, and the answer is, in some cases, yes, we still are. It really depends on our time of day and time of year here in California now, especially down in Southern California, because we have so many renewables on the grid, and the state has a plan to bring that grid to fully renewable. But if we don't even account for that renewable energy, if we just focus on the question of, okay, is it better to burn gas on site or to generate that electricity from it, we wanted to go through this study of what does that actually look like. So if you look at the natural gas approach, so this is a gas boiler. If you take your natural gas and you burn that in a furnace, you're going to lose a certain amount of that heat up through that flue. And so operationally, you get about 80% of the amount of gas you put in. So the heat units that you put in of gas, you'll get about 80% of that to the space. Now, if we look at what happens if we do use this in an electrical grid, so again, you're going to burn gas at that power plant. There are certainly inefficiencies in power plants and in generating electricity. So when you're burning the same thermal amount of gas, you're going to get about 50% of that as actual electrical energy that you can use. The difference is that on site, we're using that electricity to drive a heat pump. So the heat pump uses that electricity to drive a compressor, which pulls the heat out of the air to put into our space or into the water. So we don't have to create that heat. What we're doing is we're using that compressor to pull this amount of heat out of the air. And that's where you'll hear people talk about a COP, or a coefficient of performance, for these compressors, which are usually somewhere between 3.5 to 4. That means that for every bit of electricity you're putting in, you're getting 3.5 to 4 times the amount of heat into your space from that. So it's essentially like having an efficiency of 300 or 350 or 400% on that piece of equipment, instead of having this 80% efficiency from a boiler, which means that for this same amount of gas input at the power plant, once we get to site and we're able to pull that heat out of the air, the actual heat that goes into our space is more than the amount of gas we had to put in. And this is not accounting for any renewable energy at all. This was if the grid was entirely dirty. So this is why, as we're talking about decarbonization and responding to climate change, the push to move our mechanical and plumbing systems away from gas onto electricity, regardless of how fast it takes the grid to become more renewable. But in our case, so that would be even if the grid was not renewable. We know in California, we have the benefit of an increasingly renewable grid. Additionally, on this site, they wanted to include local photovoltaics on the site itself. And so they were doing this through shade structures in the parking area. And having the contractor there on board, we were able to sit down and work through with them. Okay, given that we've gotten rid of the gas service, we've gotten rid of the boilers, we've gotten rid of all that hot water piping, what do we look like budget wise? And the answer is that we were able to, by converting our MEP systems from gas to electric and getting rid of all of those utilities that we didn't need, we were able to save over $1 million in first costs off of that mechanical system, which would have been enough to pay for the PV system. So we would have been able to get that PV system just with our cost savings, except Kaiser went one step better and they actually negotiated a power purchase agreement. So this is a solar vendor that provided those panels at no first cost. So Kaiser did not have to spend any capital expenditure. And what they're able to do is buy that power from that vendor over an agreed period of time. It's usually about 20 years. So what we were able to do was then take that $1 million of first savings and redirect it back into the architecture and the programming and some of those finishes, because we didn't actually have to do a capital outlay for these panels initially. So that was another strategy that let us get more into this project while still working within that budget. So, and this is sort of those panels going up, and these again are being provided by that solar developer. So at no first cost to Kaiser. So performance wise, how that worked out with those various strategies, both with what John and the architectural team were able to do with the envelope and what we were able to provide with the MEP systems, we came in at an EUI for this building of 33.5, which once we decided we were going to target zero net energy, we said, okay, we don't want to just do it for the building, we want to do it for the entire site. So we took the building loads, we added in the site lighting, which bumped up that energy demand a bit. And then we also added in the EV chargers because Kaiser wanted to include a certain number of EV chargers here. Also, there's code requirements that we have those in there. And they wanted to include all of that. They said, okay, if we're going to go zero net energy, we're going to do it for the entire site. And so we modeled the total demand that was going to need, added about a 10% factor of safety to size that PV array. And that's ultimately what dictated the size of those arrays and how big those shades needed to be. Now, as we mentioned at the beginning, this is not just modeled performance. We actually have our measured performance to demonstrate operationally how this building is operating. So these first two bars are those same model that you saw on that previous slide. What we had predicted in our energy model would be the building operation, and then what that PV panel was sized to produce. You can see the building itself actually performed better than our model. So we're actually using less energy on that site on an EUI basis than we had originally modeled. And the PV panels during this particular performance period actually produced less, which is why we build in that factor of safety. We think this year was because this is when there was a lot of fires up in Northern California. So we think we just didn't get the solar exposure on those panels, and that reduced our generation. But you can see that even with that capacity reduction, we still would have outperformed our predicted energy, and we certainly outperformed the actual measured energy that the site used, which is what we were able to submit and get both the ILFI and the LEED Zero certification, confirming that we were performing net zero on this site. So just to sort of circle back and give a little bit of a recap for the different strategies that we included here on this site. As John said, it started with really understanding the site and getting the orientation right. So orienting in that east-west direction, again, sort of starting with those fundamentals of positioning the building. And then really focusing on making sure that the building is responding to the solar exposures that it has on each side. And that's really the facade tuning that John talked through in his early slides there. So on the south side, really reducing the amount of windows on that side so that we're not getting that direct solar input. On the east side, keeping those reduced. It's less critical on the east side because this gives us a little bit of passive morning warm up. The north side is where we really take advantage of that daylighting in those public spaces and in those stairs. And then on the west side, really driving that solar exposure down, just kind of those light at the end of the tunnel that John mentioned so that we don't get the solar gain from those low solar angles. And then on the mechanical side, again, kind of comparing to what a baseline system would have been with these two conventional rooftop units and the full gas boiler system, this is sort of the default typical approach. And this is what we wanted to get away from and see what we could optimize with this all electric thermally zoned strategy. So instead of that two system approach, we divided the perimeter zones off so that the perimeter zones were separate from the interior. So we were not doing that simultaneous heating and cooling in the same zones. We had dedicated heat pumps that served those perimeter areas. And you can see if you look at the bottom system, just how much more piping there is with those two boilers that we were able to eliminate when we went with the thermodynamically zoned heat pump approach. And just the reduction of material and labor to install that was able to give us that, like we said, over $1 million of energy savings at the outset of this project. And then lastly, once we had reduced those demands, as a first step, that's where we added those solar PVs to shade the parking structure and achieve all electric and also get a zero net energy building. So I think just going to a brief summary, I know that the little illustration there summarized, but I think John touched on a lot of important points at the beginning that we just want to make sure that we get a chance to recap here before we close and open up for questions.
Yeah, so again, we talked about obviously orientation and the very efficient footprint, the glazing position or the facade tuning, the envelope performance, the strategies with, I didn't mention obviously a white roof or, you know, those kinds of things, but those are all built into this. The prefabrication was both critical from a detailing and energy thermal break point of view, but also it helped with the construction sequencing, and which played right into the budget.
Yeah, and then I think on the mechanical side, what we talked about was really that zoning strategy that eliminated the reheat, and then also simplifying those systems, letting us use the smaller systems to serve those perimeter and just keeping the overall systems and controls simpler, really driving towards all electric systems to eliminate the gas dependency for both decarbonization and then also as a savings to this project. We were able to eliminate the gas utility entirely from this greenfield site. And then also looking for kind of uncommon or different approaches for getting the PV on the site through that power purchase agreement. I think this highlights some of those challenges that we talked about with being able to do high performance design in these healthcare applications.
So again, this particular view is showing you the rather lengthy space that became the private part of where the providers are, the doctors are, and their medical assistants, and how those connected to the exam room hallways that turn to the side of this. But using a very, very simple structural grid. I mean, this building is flexible as they change program, move clinics around, grow and shrink, as I'm sure they have. I know we've done some work up there. I apologize, I haven't been there recently, but there has been some modifications obviously since this first opened.
Yes, I think that ongoing adaptability, like you said, both just having a very uniform and standard grid structure so that they can rearrange the suites as they need to, because we know healthcare buildings need to do that. And then also those systems, they're conventional overhead ducted systems. So they're very adaptable to change as those suites get rearranged, which we know, within healthcare, they're going to need that adaptability. We also know that some of these, depending on the healthcare application, there's sometimes more complexity of systems. So, we couldn't do some of these passive systems throughout the entire space.
Right. For instance, there's an imaging, imaging clinic on the first floor. There's some, high-tech dermatology has some special lighting needs on the third floor. But, those are just some examples of the medical complexity. Obviously, the pharmacy has its own challenges as well.
Right, certainly. And I mean, I think scale, like this was a relatively, kind of standard office scale type project, but in some other healthcare applications, just being able to do sustainability strategies at scale can be another challenge we face. Now, this approach is a very scalable approach for medical office buildings, but in larger campus type systems, again, you just need to be able to acknowledge, design for the specific project and not try to take cookie cutter approaches. Um, and then I think within healthcare, certainly specific code and operational requirements. So privacy requirements, airflow requirements, filtration requirements, limit some of the strategies that you can take. But I think what we've been able to demonstrate is that there are still, um, plenty of options out there to get very high performing systems that can serve these spaces. And then I think just to kind of wrap up sort of where we should be thinking, as our next steps. So certainly net zero, is definitely still a goal where it makes sense and where it's applicable. But beyond just net zero, thinking about decarbonizing those systems. So, even if we can't, in a high-rise type building or in a higher energy use intensive type space, we might not be able to get to net zero, but still shifting to a decarbonized system, an all electric system, still gives us an overall climate benefit. So really focusing on the carbon aspect instead of necessarily the specific net zero certification. And then increasingly also designing our spaces to be grid responsive. So we're seeing more both active and passive strategies to make these systems resilient. So some amount of either thermal storage or battery storage, having those on-site renewables that lets the site generate its own power, really to alleviate the demand on those grids, because we're seeing our electrical grids become more and more stressed, both as the systems age, but also as we shift more systems to all electric. We're going to want those buildings to be able to be more grid responsive, to react to the demands and the needs of the grid. And then we're starting to look, so what we've spoken about today has all been a pretty strong focus on the operational carbon. So we're talking about the energy use, but really starting to look, we're looking more and more on projects looking at the embodied carbon. So how much carbon is built into that structure and into your mechanical systems, and making sure that we're accounting for that. So as sort of these future strategies that we should be looking at in our high performance buildings going forward. And then the resiliency and the durability, keeping these buildings operational for a long period of time, having a long view on these buildings. And then John, I know you had mentioned this before, was really just the community engagement. And I think this project was a great example of it, just the amount of, participation from the community in the artwork, in the public spaces. I think there's some programming that really allows for community gathering, right? Is that right, John?
Yes, there is a community room on the ground floor, as well as the healthy living store and some other functions that are tied directly to the local community in a cultural sort of way.
Great. So that wraps it up, the presentation. And John, we managed to stay on time, so good job. We've got a bit of time here left for questions. Got 8 minutes left until 5, but certainly we can stick around for a few extra minutes too if folks have questions beyond that. I see a couple of questions in the chat, so maybe we'll address those first and then open it up to other folks if you've got them. The first question in the chat is just if there's a PDF version of this presentation available. I think we can certainly share that. The presentation is being recorded right now, so the recording will be available through AIA, and we'll share a PDF version as well that they can make available. The second question was there any steam sterilization needs for this? In this particular project, I don't believe there were. John?
Not that I'm aware of
Yeah.
either. I know we had trophon rooms for medical devices cleaning, but I don't believe there was the requirement for steam as the person pointed out in a hospital.
So, I mean, I think just to kind of address what I assume is the embedded question within that is, even if there is a steam requirement, there are clean steam generators that are all electric. They do have a higher electrical load, and that's, one of those challenges that you need to offset. But sterilization doesn't mean you necessarily need gas. You can do electric steam generation. The next question here in the chat was if we modeled this MOB against a licensed clinic building with its associated ventilation requirements. Yeah, this building did need to meet air change requirements for table 4A, and that was included in the modeling. And that's one of those reasons, like we said, that we do have airside systems serving all of the patient areas to meet and maintain those ventilation rates. Question, is this an HCI 3 building? John, I believe it is, right? This is Oshpod HCI 3?
No, it is. I don't think it is.
Oh,
no.
It's not. Okay.
There's no inpatient surgery going on here or anything of the, like it's all outpatient. So I know the pharmacy has some special requirements, obviously, but no, I don't believe there's a particular licensing for this.
Okay. And then I see the comment from Eric at the bottom about sterilization killing an electrification push. Certainly the high temperature requirements are less efficient with electric. You have to use electric resistance, essentially, which is more energy intensive. You get your efficiency of 100% instead of 300%, but it's still doable. It's just a higher demand.
I did have a question, and I was really hoping this was going to be a licensed facility under HCI 3, but if it's not, that's kind of unfortunate. Calina, do you see this facility with the systems that have been put in place? Is it capable of being licensed as HCI 3?
Yeah, no, it certainly could be.
I'm just thinking, future forward, if they had pigeonholed themselves into a position where they couldn't advance it or they couldn't go beyond what they had originally built. And then the other question was the level of imagery, the level of equipment in here. Do you know what the program is in here, John?
Boy, it's been a while, but I'm pretty sure there was MRI. There was at least one MRI, if not two, and then there was also CT scanner as well as monography. But I don't remember the exact count of the pieces of equipment. Sorry about that. I mean, we could probably try and find the equipment list someplace, but
I mean, based on the building, the program, yeah, probably one CT, a couple X-ray, and picturing just not a big set for this project.
Sometimes it's fun. I'll go to their webpage and see what services they're providing. Sometimes that's a quick way to give you a clue as to what's in there.
Yep.
There's a question in the chat about Kaiser's zoning requirements and how did we get around their design standards. So we did this very collaboratively with Kaiser. And I think one of the things that's interesting to point out is that it was so successful in the implementation that they actually had us present at their preferred provider program and actually revise some of their standards to be more in line with this type of approach. And we have taken this same approach in other Kaiser medical office buildings since this one. So this was the first one we did for them.
Yeah, that's true of the space planning too. This was a set of three, we called it the triplets at the time. There were 3 office buildings that were going all at the same time with different design teams and contractors in different parts of Northern California to try and test really these latest templates, which again, they've already revised it since this building was done, since the 3 of them were done. But yeah, we were in collaboration not only with the user groups out in this particular provider area, but also with Kaiser Oakland, and as Calina mentioned, we had their national services folks, including mechanical and electrical, all weighing in on this as we went forward. And that's what I was saying. It was really cool that the sort of domino effect that happened with the ideas that, well, what if we did this, and could we stretch it to do that? I mean, it was really a fun collaboration. That was the best part of this. Obviously, the challenge to meet the budget and to meet the schedule is on the other side of the coin, as always. But it was really great to push the team in this direction and be successful at it.
There's a question in the chat, John. What is the operational schedule for this building? Do you know that off the top of your head?
I don't know. Recently, it was programmed to be your basic office hours, some clinic hours somewhere between 8 and 5-ish during the week, but the lab had an earlier opening schedule, I think 7. And also their staff often stayed a little later in the day. So after the last patients were gone, I know staff would often be there till 6-ish. There was some concern about security lighting in the winter and stuff that we had conversations about. So I believe it was basic medical office hours. There weren't any special things. Now that may have changed. Also, the building was designed security wise so that the community room and the welcome zone on the ground floor, which you actually see lit up in this picture, was able to open and be part at off hours, in other words. So that was intentional. So I'm not sure how they're using that these days, but it is pretty much a standard office hours.
All right. Well, if you do have other questions or you think of some after this, certainly both John and my email addresses, they are on the screen.
Yep.
Great.
Thank you so much.
Thank you very much for
Thank you, everybody.
hosting us. It was a pleasure.
Thank you so much. Thank you for everybody.